So Eric, we did these 8.1 notes, but it was a little rough.
Nice. Yep.
Yeah, we both had told them there was a lot of theory in it. And so I did not do my 8.1 worksheet number 1 for one thing. Okay. So if you have a chance, but the last page of the 8.1 notes, which was, we didn't get a chance to, I just had them do it themselves basically.
Okay.
And said maybe we could just check the answers. We got it set up, so it was paid, yeah.
This one right here?
That one right there.
Gotcha. Okay. Let's do it. Do we need to start back here, or 197 is done?
Yeah, 197 was done. Oh, you know what though? This class we did stay. Did you guys, I can't remember. Brianna, I know that you stayed. Did we actually finish it? I know we didn't in the night class. Because it was over by like 15 minutes, but I know a few of you guys stayed with me. Laura was on that day as well. Do you guys have your answers filled in for that? Or, so this would be page 198. What I'm remembering is for the day classes that we just got these set up. Like I helped you write the probability statement for B. And then you would have needed to go to your StatCrunch to actually figure out that out.
Let's do it. We'll just run through it.
She said we
did. You did do them. Oh, okay.
Definitely night class we did not, Eric.
Okay. We'll do that tonight. How about, okay, Reagan, how about I'll just write out the answers real fast and you can check them since one of you hasn't done it. That sounds good.
So Reagan, yeah, it'll be in the Thursday recording. And it sounds like we did do the whole thing.
Yeah, I started to watch it this morning before class, and I was just gonna finish it after. So when I finish the recording later, yeah.
Yeah.
Okay.
No problems.
Okay. Well, then let's no worry, Taylor. We're just deciding exactly what we're gonna do. Yes. You missed nothing. Okay. Well, then let's just do the worksheets. We'll start there. How about that? And maybe I could try to say what this is about. Why is this not working? Why not? So what's happening in chapter 8 is we're looking at the theory of how we're able to use one sample to make an inference about a population. That's the big deal. So if you remember from 1.1, we did this thing where we started with a question, which from that question led to the definition of a population. And from that population, we drew a sample. And from that sample, we got a bunch of statistics. And then this is what we did, what we just finished with the midterm stuff. And what we're just now starting is, how do we then take this sample and make an inference about the population? Well, how do we do that? So how do we go from saying we know X bar equals this number, so because of that, we know now mu equals this particular number. And that's what the central limit theorem is about. It's the theoretical foundation of how we're able to do this for normal distributions or data that are normally distributed. There are other data sets that have other distributions. So here's what we do. Here's what chapter 8 does. It says, let's say we have a population. And let's say from that population, we're going to calculate, we want to know the mean salary. So let's just say mean income of people in this thing. So what we do is we draw a sample 1. We'll call that size N. And actually, no, we'll just leave it N. So let's say we take 50 people from our population and we calculate an X bar. And that's the X bar of the first sample. And then let's say we decide we want a new sample. So we do another sample and we keep it the same size and we calculate a second X bar. And then we do another one. X bar 3, again, same sample size. And we keep doing this. We'll say X bar or X bar K. So we get a bunch of different samples. How are you doing so far, everyone? Does this seem reasonable? Does it make sense what I'm talking about? Let's say instead of putting K, let me put a number here because that often confuses people. Let's say we drew 100 samples, all of size 50, and in each sample, we calculated the sample mean, the X bar. So then we create a data set of statistics, and this data set is X bar 1, X bar 2, X bar 3. So it's a bunch of means, right? And we have 100 of them. And then we go into StatCrunch and we enter all of the means and we calculate the mean of the means. So this is a bunch of data values, but it's not actual incomes, it's mean incomes of 50 people. Well, when we go into StatCrunch and we calculate those means, the mean of those means we call mu X bar, and it should be equal to the mean of the population, provided those 3 conditions are met. If what we've been doing is we've been selecting an individual from a normal distribution and calculated the probability that they are between particular numbers, and then we're like, hey, 20% of the data values are this. Well, now what we're doing is picking 50 at a time, calculating a statistic from those 50. And then the central limit theorem, if it's met, says, hey, we can use the mean of those means to determine the population mean. What's backwards about chapter 8 is we're saying we know this population mean. And so we're just saying, oh, if we have the sample, or if we know the population mean, we know when we do samples, their means will be this. What we're going to do in chapters 9, 10, and 11 is say, we don't know this, but because of the central limit theorem, we can get one sample and use that one sample's mean to approximate the population mean, instead of getting like 1,000 samples and taking a mean of those means. Ugh. May or may not be helpful, but that's the idea of what we're doing here. Now, I forget which one we're doing. I can look it up. Is it number 1, number 2, or number 3, Cindy?
Mine is number 1.
Okay.
I'm making the assignment sheet right now. Sorry, guys. I got busy yesterday.
So this is our 033?
Yes.
For Cindy's worksheet. Let's start here. Before we even do that, so this is 635. Let's go back to the thing that you're going to use on the final exam, the appendices sheet, and note that the chapter 8 stuff, the central lyric things, everything you need to know is right here. You don't have to write anything down on your reference sheet for chapter 8. You just need to know these 3 conditions. You need to know when those 3 conditions are met. These are the 3 results. So you're going to be using this a lot, and this is pretty straightforward. And then this is how you do it in StatCrunch. So this first worksheet, page 635, is this first problem is applications of the standard error of the mean. Now, standard error is just a fancy name for standard deviation. And it's a standard deviation of a data set that all consists of means that were pulled from a bunch of samples. Whew.
So yeah, so Eric, what we were mentioning is that when they go to StatCrunch, what I found was the biggest mistake being made is that they were wanting to put in the population standard deviation rather than the the deviation from the sample means.
All right, so let's practice that.
Standard error, basically.
So we have so also there's the three symbols for it. There's SE X bar, there's sigma X bar. Those two things mean the same thing. So you'll see them used interchangeably. I tend to stick with sigma subscript X bar when I'm doing things, but you'll see them throughout. Like, for example, here you're finding the standard error of the sample means. So just recall that this is S, the sample standard deviation, divided by the square root of n. So for this one, I'd say use Desmos. Let me give you 5 minutes and see if you can calculate these. This is just straight, can you type stuff into a formula? That's all this is. And then also try this one, remembering the connection of what happens as the sample size gets larger. All right, 5 minutes. Oh, my phone's upstairs.
Am I muted?
Okay, so we're lost. Gotcha. Sorry. I could have, sorry, I went upstairs and took too long. So what you've been handed here is a sample standard deviation of 5.34 and a sample size of 20. And you're supposed to calculate this standard error, which is the same thing as this sigma X bar. So I'm going to use the sigma X bar. And you're literally just doing the formula. S is on top, so put it on top. Slap in your division symbol, square root. Slap in your n, that's 20. Figure out what that's equal to approximately. So 5.34 divided by the square root of 20. There it is, 1.19406.
Yeah, so round to 3.
Okay.
Since it says 3, it actually does tell us for a change.
For once.
Exactly.
There we go. Brianne, is that helpful? Awesome. I'll let you do the other two. I said you're welcome, realizing I was muted. So how are y'all doing? Y'all feel like you got the rest? I'm thinking we probably maybe don't need a whole lot more time, because then the next two, you just have to change the 20 to a 30 and then to a 40. .975. What do you notice about, well, actually, let's think back a second. What is standard deviation a measurement of? Anyone remember?
Spread.
Nailed it. So it's how far apart the data values are. So if you look at this, we've got a sample standard deviation, and this is the population standard deviation, the sigma, for these means, right? We're trying to figure out what's the population mean of this data set. And if we get a larger and larger sample size, yikes, then the spread, how far apart the sample means are, they all get closer and closer and closer to the population mean. That's what you're seeing happening in this calculation. You're also just practicing using that formula. How do y'all feel about this? These are the four distributions. So note the population has a mean of 28.7 and a standard deviation of 22.2. Oh, okay. Let me give you a couple seconds to think about it. Like a couple minutes. Let's take 2 minutes. Definitely, Taylor, definitely. Let me see, I want to do. So while you're doing this, or really, in my opinion, any problems, your practice problems, you should practice using your tools that are going to help you with the final exam. So, I thought I said stop. Okay, so what this question is getting at is condition 3. So condition 3 says, in order to use the central limit theorem, in other words, in order for this formula to be true and this to be true about the mean of the sample means being the same as the population mean of the data set we're working on, either the population itself that we drew our samples from have to be normal with no outliers, think 7.3 graph, or the sample size has to be, quotes, large enough. And this number that makes it large enough is 30. So if we get back here, what that means is the larger our sample size, the closer to normal the distribution of the X bars is going to be. So what's happening here is we've got some population of data values, this, and it has some sort of mean that's like right here ish, right? And then there's some median, or maybe it's not right there, but this is the distribution, and it's skewed right. And so what we're doing is we're taking samples of size 2, 4, and 10 from this population, and we're calculating a mean from those samples. So if this was the number of hours of sleep per night, right? We pick 2 people and say, how many hours of sleep did you get last night? We add together their amounts and divide by 2, and that's the X bar that comes from the sample size. And we do this a ton of times, and we get these 3 different sample distributions of X bars. So these are data values. These are means. These are all X bars drawn from this population. So the smallest sample size will have the mean that is the least normally distributed. They'll have a bunch of X bars kind of all over the place, because some people get like 2 hours of sleep per night. Some people get 12 hours. And so if we're picking 2 people at a time, what if the first 2 both only got 2 hours of sleep? Then their average hour of sleep is 2. And what if the other 2 we picked both had 12 hours? Their average is 12. That's really far apart, 2 and 12. And so when we keep doing that, we're going to get a bunch of X bars like all over the place in terms of means. So that's going to be this middle graph. These X bars are just kind of, there's just 2 in their sample size, so they're not going to be close to the actual mean of the population. Well, if we get a slightly larger one, say size 4, we're now asking 4 people, how many hours did you sleep, adding together their full amount of hours and dividing by 4. And now, we could have a mix of things, 2, 2, 12, 12. We could have a 6 and an 8. And so the sample sizes, or the sample means, are going to be less spread out with the 4. And then even less spread out with the 10. There's a conceptual reason that works here too, to help understand what's happening. If you think about, if we wanted the actual mean of the entire population, we would get data from everything in the population, and that would just be the mean. So if our sample size gets closer and closer to the size of the population, just because our sample size is larger and larger and larger, we're going to get closer to the population mean anyways. It just turns out the largest we need when calculating means is 30, no matter how large the population is. Boy, I just said what happens here. But I guess I could write what I said. What's going on with this? So larger sample sizes will have, what did we say? We'll just say smaller standard errors. Taylor, is that helpful at all? I mean, and I'm asking you specifically because you asked about this, but for everyone, is this getting helpful or not so much?
Yeah,
I answered that question with, is n goes up is an arrow, n goes up, the spread goes down.
Love it. Okay.
Because I'm lazy.
That's usually what I do too, actually. I just forgot about it.
Eric, you are rubbing off on me.
Oh no, Cindy, this is bad. Okay, so number 3, anytime you see explain whether it is appropriate to use the central limit theorem, what you're being asked is, have these 3 conditions been met? So how I like to do that, and how I like to ask you to do that, is just to write them out. And I tend to keep them in the order that they show up here. So condition 1 is random. Ask yourself, has that been met? Tell me how that's been met. Condition 2 is independence. Find out how that's been met in the data set or the prompt. Condition 3 is normal. Find out how that's been met. So if you haven't watched the videos, that's okay. I would encourage you to go watch them at some point. For now, just read each one of these sentences and see if you can identify how it's met up here. So let me give you like 4 minutes to try that. And then if you get absolutely stuck, we're obviously going to go over it. Set a timer for 4 minutes.
Can you put that other screen back up, please? With the, yes, thank you.
This is page 268, if you need it.
And just a reminder, you guys, if you read your little prompt thing, and for example, condition 1 says random, then you can just write as your condition 1. Remember, we just said the word given, that it was given in the problem. And that's all you have to do.
In fact, that's what you're always going to do.
Yeah, unless random, it will say random.
Every single time. Okay, how we doing? What'd y'all say for normal?
I said it wasn't normal because 15 is not greater than or equal to 30.
Excellent. So let's see. Fail. 15 is not greater than or equal to 30, which means the central limit theorem does not apply. It can't be used. For independence, this also was given. We often don't say independent. You're often going to have to do is the sample size less than or equal to 0.05 of the population size? And we're going to look at one like that. But in this case, it was given. So because condition 3 fails, we cannot say anything about the mean, the standard deviation, or the approximate shape of the sample means that we would be drawing from this population. Cool. Okay. So now we're doing a random independent sample of size 33. Oh, look, that last condition has now been met. So the central limit theorem does apply to this prompt. And we are going to, you're going to state this. What question A is doing is simply asking you to identify these 3 things. So when the central limit theorem applies, when these 3 conditions are met, these 3 things are true. And you may or may not remember it. We already did this. Describe the shape of the distribution. We did that back in chapter 3 when we said, what's the shape? It was either normal, skewed left, or skewed right. What was the center? It was either the mean or the median. What was the spread? It was either the standard deviation or the interquartile range. Well, when the central limit theorem is met, the shape is always normal, the center is always the mean, and the spread is always this little formula. Okay, so take 5 minutes, see if you can't fill out the results, the consequences of the central limit theorem, and then do these calculations in StatCrunch. A word of caution, these calculations are the same way we did them back in chapter 7, except this thing, which Cindy said is the thing you all were messing up anyways, and it's what everyone messes up, so don't worry. And that is, you're not going to use 12 as your standard deviation. You're going to use sigma of x bar. Okay, 5 minutes on this one. Unless anyone has questions. Are we doing okay?
Can you, I already messed that up. What do we use? Or how do we find that? Oh, do we do the n?
Yes.
Divided by the square root of n? Okay.
Yes. So it's going to take sigma. I'll just write that little formula there. Sigma divided by the square root of n. That's what we're going to use here. And I would do 3 decimal places on this. Brianna, what is that for? The standard error? The 14? Okay, so it should be 12 divided by the square root of 33, which is 2.089. How did you get that 14? Point whatever, 14.797. I bet you used the 85. Yep, okay, no worries. That's the mean. So the formula, I know my handwriting here is really bad. The formula is the sigma goes on top, not the mean. No worries. Easy fix. This one is 85. Okay, that was 5 minutes. Are we ready to look at it? I'm going to assume yes. So this thing is normal because 33 is greater than 30. And maybe it's worth noting n equals 30. N equals 33 is greater than or equal to 30. That's condition 3. That's what this one is about. This part is about condition 1. This part is about condition 2. So I encourage you to start thinking in terms of condition 1, 2, 3. The order that you list them doesn't actually matter. I'm just trying to be consistent with what's in the reference sheet. And I think it's helpful sometimes to just always list it the same way. Okay, so the rest of these is just smash them in StatCrunch. So we're going to stat, calculators, and normal. And we're putting in 85 for the mean, and I'm putting in 2.089 for the standard deviation. That is the standard error of the sample means. So notice we have here X bar, and this says X. So StatCrunch is always default to X, but these are really X bars that we're working with. All right, we just want greater than and 90 and compute, and there it is. So this is 0.0083. And if we wanted to shade, we could. Is that what y'all got? Next one is a between one. So 81, by the way, recall that StatCrunch default doesn't change the mean and standard deviation as you click through these until you change them. So there it is, 0.8565. Troop, yada, yada. Okay, and then the last one. Did anyone get stuck on this one? Or let me ask you this way. What is this telling us, an area or a X bar value? In other words, what does this mean, y'all? What is the 5th percentile telling us? Love it, Kayla. It's a Z-score. Excellent. Is it? Wait a minute. Let me think.
No. It's an not. Area at or below.
Sorry, Kayla. I got excited by Z-scores. A percentile is, so the way we write this is P5 and it's equal to something. And what Cindy said, totally right. It's the area associated with this particular number that is at, it's like above, at or above 5%. I don't know how to say it. It's going to look like this. X bar is less than some number and it's going to equal 0.05. That's what it is. Z-scores are, we could calculate a Z-score for this because we know the mean and the standard deviation. Once we know this number, we could do a calculation for that. But otherwise you're looking for a Z in our thing. And with this stuff, you're not going to see standard normal things with sample means and proportions, which is what 8.2 is. Okay, how are we feeling about this, y'all? Any questions on what you just saw? Okay, so for my class, I believe it's the worksheet number 3.
Actually, Eric, you have in number 2, but I say you do whatever one you want because we can switch the number.
Let's do number 2 because it's basically the same thing.
Yep. Okay,
y'all. Now's your time to prove that your silence means you know it, or to get noisy and tell me what you don't know. So I'm going to give you 5 minutes to complete number 1 and 2. Very similar questions to the previous one. And if you've watched the videos, you already know the answer to C. So we'll take 5 minutes on this front page and I'll check in to see where you're at. Okay, Taylor, I like that you're saying that. What do you need help with? Is there something from the previous? Okay, here we go. Nice. Starting. Okay. Did you read the question and figure out what you're being asked to do? Like, what is it? What is the question you have to answer? That's the first thing I want you to tell me. Or the information you have to find or whatever it is. Ah, nailed it. Excellent. You know how to start now. See, that's the first thing. Figure out the question. Now, do you know a formula for standard error? This is the trickier part, right? Because now you have to put together all the information. And you can just say, yes, I know the formula, or no, I don't. Oh, wait, here we go. Let's see what you said. Yes, Brianna, that's it. It's right here. This is the formula. So if you look at the formula, what it is it's the standard deviation divided by the square root of the sample size. If you're forgetting what these letters stand for, those are the words for those things. So who knows the standard deviation? You can type it, you can mic it. Nailed it, Taylor. Nailed it, Alexa. That's it. That's what this stands for, standard deviation. If you notice, this is a StatCrunch output. So this is how StatCrunch states it. So yeah, that's it. So we know that. Do we know the sample size? Okay. Do it. Set a timer for 5 minutes. And then let me know when you have the answer. Okay, nice. Y'all got it. So I have a slightly different. I think I typed mine wrong. Hang on. 24,418.94. 24,418.94. There we go. Divided by the square root of 25, which is 5, and we got 4283.788. Nice, Brianna. Taylor, you were really stinking close. Did you just type a number wrong somewhere for that 43 instead of 83?
Yeah, I mixed up the numbers.
No worries. But you got, like, that wasn't so bad, right? I mean, there was a lot you had to do. So you had to figure out what's the question, which in this case was a computation. What's the formula for that question? Yes. So oh, let me stop this timer. Stop it. There we go. Yeah, very easy to do. You may or may, I mean, if you didn't know the formula, right, then you're stuck, like you can't do it, but you just need to know where to find it. Okay, so let's look at question 1 then. What are you being asked to do in question 1? This is the second question 1. So I think this is supposed to be question 2. Okay, verify we can use the central limit theorem. Love it. Okay, so it says verify that the conditions. I like what you said, Taylor, number 1, 2, 3. So you're just doing 1, 2, 3. So do it. In fact, maybe I bet you could do all the rest without my help. Maybe not C, maybe C if you remember it. So let's do 5 minutes and you work through this. If at any point you're stuck and you can't do any more, tell me and we'll get you unstuck. Okay, that was 5 minutes. Y'all ready? Okay, what'd you say for condition 1?
It said a random sample of 85.
I typically write it like this, and given. Excellent. It's given, yep. Condition 2, independence. Was that given?
No.
Okay, so did you say yes? It's their samples are independent of each other, or the households are drawn from the population. Each drawing is independent of the next household that's picked. What did you all say for this one, or did you get stuck on this one? Okay, so if it's not given, all right, nice. Let's do this. So if it doesn't say they're independent, sample observations are independent, then there's 2 ways that we know they're independent. Either it's collected without replacement. It doesn't say anything about the households are drawn with replacement, right? So we have to assume this is the case. You always assume that drawing is being done without replacement. So then what has to be true is that the population must be at least 20 times larger than the sample size. In other words, by where this 0.015 comes from, that's 1 over 20 converted to a decimal, 0.05. So that's what this little where this little formula comes from. So if we go back to our problem, we know n, right, is 85. So we just need to show that 85 is less than or equal to 0.05 times the population. Now, can anyone describe for me the population in words? Or if you know the number, tell me the number. That works too.
The TV sets in a household in 2013. So like all TV sets in a household in 2013.
Nice. I like that thought. You're close. So what we're doing, our sample is 85 random households. The data is the number of TV sets in that household. So you've correctly described the variable, but not the actual population. Does that make sense? So maybe another way to get at the population, it's what we did back in section 1.1, like the first day of class. How do we, what's the sample in this problem? You'll see what I'm underlining. What is that? Or highlighting, I guess, is what I'm doing. What is this thing that I'm highlighting?
That's it, Kayla.
Nice, Kayla. That's it. Right. So remember back from 1.1 when we talked about, hey, if you can identify, the sample is usually the number, 85 random US households. And then to change that into the population, you just replace the number with the word all, and that typically works. Of course, there was that one problem about the exercise. The sample was like women over 60 or something, and exercise and all that. And that was kind of a weird one. So this is what I want to see. Now, what do y'all think? Is 85 less than or equal to 0.05 of all US households? Does anyone know that how many households are in the US? You could just Bing it. Number of US households 2022. Oh, there's 128 million.
Well, were you supposed to do 2013 since that was the year?
Sure. 122.46 million. Now, you might be sitting there thinking, I don't have access to Google when I take the exam. How am I supposed to know this? Well, we're hopeful that you see this and you're like, yeah, that's definitely true. There are lots and lots of US households. I looked up the number just to prove that point. You know, there's 122 million US households in 2013, and now there's 128 households. I don't even know what the definition of a household is. Oh, here it is. Households and families are the basic. Okay, we're not going to take the time to read that. But anyways, so this is what I'm looking that you do. It's rare that we actually give you the number. There are a few worksheets where you do get the number for the population. So use the number if it's given. Otherwise, just state it and then say, yep, that's obviously true.
So remember, you guys, I called it magic. I said, because of magic, it works. Or yeah. It's really logic, really.
We used to show the calculation of what happens with the probability when they're not with replacement and you have super large numbers and how it's basically the same, but that's, yeah. Essentially, if your denominator is large enough, 85 doesn't make a difference. Okay, what'd you all say for normal? I'm assuming you did this. I think we'll just say, hey, 85 is greater than or equal to 30, so check. Done. All right. Did you get part B? Or actually, let me try again. What did you write out for part B? Describe the sampling distribution of the sample means. All right, Alexa, tell us what you did.
So I did, I said it was normal because 85 is greater than or equal to 30 or 33, sorry.
Good.
And then to get the center and spread, like this was the part that I didn't know if I did it right, but I did 2.24 divided by the square root of 85, but I didn't know. And then I did that with 1.2, but I didn't know if that was what I was supposed to be doing.
Love it, Alexa. That's really stinking close. So for the center, there's no division. If you look at what it says, the center, it's just the mean of all the sample means is the mean of the population.
Okay.
So in this case, it's just mu of x bar equals 2.24. Bam, you're done. But you did the correct thing for the second one, and that is the standard deviation of the sample means is the 1.2 divided by the square root of 85. Love it. 1.2 divided by square root 85. 0.302. I don't know how many decimal places we're supposed to have here. Okay. This is what I like to see. If you look at what's on the screen here, these two things mirror what's here, right? I've written them in the same order, kind of the same stuff along the way. That's how I like to see it. You don't have to do it that way. I just think it's helpful to do it the same way from the textbook and all the rest, and then it helps give you structure to know that you're answering it correctly. Anyone have any questions about these two things? When I have graded final exams in the past, I've seen questions that look awfully similar to what you just did. A test that you understand the conditions of the central limit theorem, and then that you understand how to write up the consequences of that. Because then we use these two things to do calculations. What's the probability that the mean number of TVs is, let's see, is more than 2.5, which is what question C says. Now I'm going to guess that Cindy gave you the 3 answers to this for a question. Do you remember the 3 answers? I don't care about the order, because there are only 3 options of what could have happened. Maybe we should read this first. So suppose we get a sample of size 85. Hey, that's what we were doing up above, right? And they had a mean number more than 2.5. That's what I've written here, which is very unusual. We could go calculate this probability if we wanted to. Might be worth doing it just to help you see the connection there. We know this is unusual because it's less than 0.05. That's the unusual marker. So what are 3 conclusions we can draw about this particular sample? Y'all know them?
I'll give you a clue. They're on page 198 in your notes. Obviously, if you haven't filled those in yet, you won't have them, but.
It's the same answer as J. Oops, is that too much of a clue?
Nope, nope.
So if y'all don't have them, let me know and we'll talk about them. I'll give you like 2 minutes to find. Oh, there we go. Biased sample. Yep, that's one of them. So it could be our sample includes houses that are really close to Best Buy. I don't know. Nice. Fluke. Yes. Fluke meaning stuff happens, right? The probability isn't 0. I like to say just this, like this is what we mean by fluke. This was not equal to 0. But really, I'm most interested that you know these 3 things, fluke and then bad parameter. Now, bad parameter means, hey, COVID happened, so everyone bought a TV because everyone was trying to survive staying at home alone with nothing to do or running out of things to do, right? I think, didn't TVs fly off the shelf? So this means the population value we know has changed, is what I like to say here. Bad parameter, population mean, that's redundant. Let's just say mu has changed for some reason. Because that mu that they had from before, they did a similar thing where they took a bunch of samples and they calculated it. And then they just said, this looks like the population value. This question typically is on the final exam. So I would get comfortable knowing these 3 things and then knowing when you're asked to use these 3 things. Cool. Okay. One more start to finish problem. If you need help with this, I'm going to do 5 minutes on the clock. Look back at the worksheet we just did here. It's essentially the same question as page 636. I think we got plenty of time to do it. So have at it. Set a timer for 5 minutes. Sarah, how far up do you need me to go? Just right there? Or?
So Eric, I'm working on writing the assignment sheet. Are you planning on doing chapter 8 project on Wednesday?
Oh, good question.
I don't want to put it on there if you're going to say no.
Let me even see what it is. Oh, that's what we're supposed to do today, isn't it?
I'm not sure if we'd be able to, since we haven't done 8.2. I don't remember what this one is either.
Oh boy. Let's maybe pass.
I get it. I'm all for that.
I'm gonna go delete those from the assignment list. I don't think
anybody's gonna complain about that.
I don't think so.
I've done that project, but I did it with nope. I did it with Chris Sweeney, and he had to make a video for it because they were so lost. I've tried to share that video to other classes, but since he was the owner of it,
sure,
it doesn't let me share it anymore.
I mean, we do it. We kind of do something like it in chapter 9. No, we don't. No, we don't.
I don't think it's worth doing. All they did was got confused, and basically he did it, and they just. I don't think it helped them at all. Is what I was gonna say.
Yeah, I think the technology will be more in the way.
Okay, sounds good to me.
Yeah, gone. It is gone. Thank you, Brianna, for that reassurance. How's everyone doing on number 2? Do y'all feel good about your answers? Well, or maybe I should just put in A and B, and if you got those right, then we're good. Because you have to have C in order to do this problem. Is this what you all had for A through C?
Yes.
Nice. Okay, then you got the rest right. Maybe. Let me just get this approximate number because I'm going to need it too. 2.755. Awesome. Did you all get these then? These last 3? I'll just get the numbers typed in and you all tell me. So I'm getting 0.2192. 0.0348. Ooh, the third one. So less than 0.75. We may need to talk about this one. Your reminder here is that Q3 is equal to P75, which means we're asking what's the probability we get a sample mean less than some number being, and then that result is 0.75. Oh yeah, look at me not shading. Like I certainly don't want to. But I think it's important that you do, so that, because it's a great way to check if you got the right answer. And I also want you to be able to keep the connection of the graph here with the number, because the two are the same thing. Ooh, fail. What is wrong with this? There we go. Okay, so which of these do you all need to talk about? And there's still some answers we have to put in there. Like E, it said, would this be unusual? So is this result, this probability being 0.0348, is that a marker for unusual?
So what percentage is unusual? There you go, Reagan.
Nice. So our answer is no, it's not unusual.
How about yes?
Just seeing if anyone's there. I will say, when I graded the exam, I had some answers like that. Some people said, yes, this is unusual because this number is greater than this number, or there were some answers where that was like that. They said no when the number was less than 0.05, or the more common one, it was the chapter 5 section on the midterm. Yes, because they're all less than 0.05, or a number was less than 0.05 when it wasn't, was the claim.
So Eric, can I just mention real quick, because
Please,
there was one on my quiz last week that was just like this, and it was exactly 0.05, or it was exactly 2 standard deviations. I don't remember which one it was, but remember that it has to be less than. So if it is exactly either 2 standard deviations or exactly 0.05, then it's not unusual. So unfortunately, the one they gave you, it was a true false question. And if you guys happen to miss that, it should have been the answer false. It was exactly, and I can't remember if it was 2 standard deviations or less than 5%. I think it was, they were showing you standard deviations. And it was exactly 2 standard deviations. It was mean. It was a mean question. But it has to be less than that. So if you miss that true false one, that's why.
Well, and if you want to, to me, there's a conceptual reason why we have to put a line there, right? Like we have to have a fence where it's like, here's unusual. That's not how you spell it. And here's not unusual. And so the line is 0.05. And so you have to decide, does 0.05 go with unusual or does it go with not unusual, right? Like, what is it? We can't have a number that's no man's land. I guess we could. So it's been done here. It's dumped on that side. So we're just saying anything below this is unusual. Anything equal to this or above this is not. So yeah, if that caught you, hooray, it won't get you next time. Okay, so that's it for 8-1 practice. I'm wondering how you feel. Do you think you could do this on the midterm? And there's a quick way we could check. I mean, on the final, there's a quick way we could check. Did you hear about the sample final exam that you're going to turn in to be graded? Nice, Taylor. I love that. So if you go to page 745 of your course pack, I believe this is the very last thing in your course pack. 745 pages away, you hit the last assignment you're going to turn in. You're going to turn this in before the final exam. We are going to help you with it. This is a review of, oh, we didn't go over F. Good call, Brianna. Let's go back to that before I get too carried away. Worksheet number 2. Nope, that's 8-2. Come on. Worksheet number 2. There we go. And letter F. So the only thing that's special about this is you have to remember what third quartile means. And we did a bunch of these in chapter 7, right? Second quartile, first quartile, third quartile. It means 75% area. That's what it means. It's P75 or Q3, and you just have to keep track of that's an area. So you put it in the area section of StatCrunch and it spits out the number. The other thing is it's less than area or left tail area. The nice thing is, by the way, if you look at your reference sheet, why do I have this here twice? The reference sheet gives you a lot of stuff to help you remember. Like notice, like it's got the output thing right here where you put the mean, and it literally says put mu here, and here it says put SEX bar. That's what you put in, and then it's stating, okay, this is where the area goes on the right side of the equal sign, and then your number for X bar goes here. And then it's saying, here's the things we've given. If we're trying to find these 3 things and we know an X bar, type stuff in here. Here it says, if we're trying to find X bar, and we're given area and whatever, type the stuff in here and it spits out the X bar. So we've given you all this helpful stuff. We just want to see that you know the words that connect it all, which really the only way for that to happen is for you to practice it on your own. Well, to see it with us and then practice it a bunch yourselves. So I was going, Brianna, does that help you for F? I don't know if you actually had any questions, but this is the answer. Maybe that's the other thing I should make clear. Okay, good. So let's go for some extra practice. So I was going to show you the sample final exam. I'm not going to do those questions with you because that's where you should really, I want you to kind of do this whole thing on your own all at once, but I just want to highlight that it's here, and it's a great place to go look at practice problems. You can see the first set of questions looks an awful lot like the midterm. And you have the midterm hanging around your house still. I'm assuming somewhere on your computer, you could look back at that. Here, number 16 is similar. The final might be a little bit longer than the midterm, not a whole lot, maybe a page longer. So number 16 is very similar to what we just did, but there was something else that I forgot to show you. In the appendices, I believe these are green or yellow sheets. There was these Appendix E, practice problems, final exam review, all chapters, page 399. So this is just a huge list of problems, and there's an answer key at the end. Taylor, you take that exam on the last day of class, which is, we'll do it the same way we did the midterm. We'll have the Zoom on, and you'll come in, and then I'll email it to you, and you'll sit there with the camera on looking at your workspace, and
I believe it's December 14th.
That looks like, yes, this looks like the last day, because the last day of class or the end of the semester is like the 17th or something. So our last meeting time is the 14th. This, by the way, we might have a final deadline on the 11th. I'm probably going to have a deadline on the 11th for all worksheets and things, with the exception of maybe the final exam could be due Monday night. So I am going to put a strict hard deadline a little bit before the final exam, because I want you to do all that work as study for the final exam instead of trying to find answers for that work. Often what happens is when you come down to the last minute and you have stuff you need a grade for, you don't really do it well. You just try to find someone to give you answers. So I'm going to put a kind of a hard deadline a little bit earlier than the final exam. And that's hopefully to help you all. Okay, so I'm trying to find a question here that looks similar to what we just did. And then I'll tell you the page, and then we'll do it together. We're getting there. We're getting there. That's a good one from chapter 7. That's similar to what we just did. Yeah, chapter 7. More chapter 7. Some more chapter 7. All good practice. Here we go. So go to page 416 and see if you can't answer number 22. Start to finish. I'm going to give you 5 minutes, and then we'll go over it together. No, this is a proportion. Never mind. We can't do that one. Okay, page 417. Go to page 417, and I'll give you 5 minutes to try this.
That says proportion
too. Why does it say proportion?
It shouldn't, though, should it?
No, it shouldn't.
Because it says standard deviation and mean.
Yeah, so change this word to mean, because we're talking about means. So yes, these should all be means. Oh, no, they're using the word proportion here for probability. So that's probably going to be a little bit confusing. Think of all these as the probability. Or think of this as what percent of the baseballs, meaning area or probability. This problem might have too many extra crazinesses. Well, let's try it. Let's see what you'll do. If you get stuck, please call on us. Okay, 417, number 23. Set a timer for 5 minutes. Okay, y'all, that was 5 minutes. Anyone have an answer? Yeah, because this is like chapter 7 stuff. I threw you all to the wolves on this one. Anyone survive? Okay. So I'll do the first one and then we'll do something else, or maybe you all will be happy. So this isn't a sampling distribution of sample means. If you read carefully, so we're like, hey, look, the Major League Baseball rules, you have to have a ball that weighs between 5 and 5.25 ounces. We've got this factory that makes baseballs and their weights are approximately normal. Awesome, we needed that. Oh, there's a mean of 5.11 and a standard deviation of 0.062. So this says what proportion or what percent of the baseballs produced by the factory are too heavy. Well, that means to be too heavy, we have to pick a data value, a baseball, notice this is X, not X bar, greater than 5.25. If we can get this probability, we know what percent or what proportion of the baseballs are too heavy. Notice how this is a similar to question to what we were just doing, right? We're using this StatCrunch calculator. We're putting in our mean. We're putting in our standard deviation. The difference is we are not having to calculate a standard error because we're not calculating with an X bar. I got the wrong answer in here. So it looks like 0.011. Okay, this is one of those annoying ones. 0.20 is the answer. So if we're saying what proportion, that means 1.2% are too large. How do y'all feel about that? Tell you what, I'm just going to go back here. I think this isn't the same stuff we were just doing, even though it kind of is. This is really chapter 7, which is like nice for me to see if you can think on your toes, how much stuff is sinking in. Let's go back to the 8-1 worksheet number 3. And how about you try question 3 from start to finish? Let's do that. All right, so this is exactly what we just did. And it's putting almost all 3 things together. You all there? You all with me? And what I'm asking you to practice here to see if you got it. If you could type a yes or say yes to know you're there. If you're not here, that's fine too. I don't want to waste anyone's time, mine and Cindy's included. Sometimes it feels like I'm talking to a video camera, and that's it, which is okay. Nice, Brianna. Yes. I just threw you like right to a final exam question is what I did. Cool. Okay, so try this one. This is directly related to what we just did. So I'll do 5 minutes and then we can talk about it. Again, if you get stuck, I was hoping you'd scream at me on the last one that you were stuck and had no idea what to do. I'm happy to intervene. But you have to call on me. Okay, 5 minutes. Here you go. Okay, where are we at?
I just started C.
Nice. Let's make sure we all got the same thing for B then. Shape, I'm assuming everyone has. Center, what'd you all get for center?
$106.
Nailed it. The mean of the population will be the mean of the sampling means. Love it. What'd you all get for the spread? I'm guessing you did this. 8 divided by the square root of 42. $1.234. That's a fun number. Too bad the next number wasn't 5. Excellent. You need these two to answer C and D. All right, so I'll give you 5 more minutes to keep going. Yeah, I guess we got 5 minutes. Set a timer for 5 minutes. Is this what you all were thinking? I kind of changed my mind based on the amount of time we have left. That for C, we're looking at X bar being less than 107. So we need 106 and 1.234. And we want this to be 107 and less than, and you got 0.79. 1, and that looks something like this-ish. Excellent. Okay. And then here, 20th percentile, remember that means P20 is equal to something. And so it's a less than area for the 20%, which is 0.2, and we get 104.9614. Awesome. Anyone know the answer to E? Can you just type the 3 things?
The fluke.
Nice. What else? Fluke.
Bias sample and bad parameter.
That's it. That's it. This is a type of question that tends to show up on the final exam. We give you a prompt and ask these three things. Show me the three conditions are met. Show me you know what that means. Do some calculations. Hey, if we get an unusual result, what are the three things that could explain that unusual result? And this thing is important because scientists do all kinds of work and then they get these results, right? And then you have to think through, okay, do we now make a statement that coffee causes cancer, or do we just say, you know, really our study ended up not being very good or whatever? And these are three things we can look at when we get results from our study that are highly unusual. Okay, I want to just mention what's going to happen to you tomorrow night, or not night, but tomorrow. 8.2 is almost exactly the same thing as 8.1, which is good news and also bad news. So the good news is that 8.2, we introduce, or the bad news is we introduce a new statistic. It's called a proportion, which is a fraction. You're going to learn about that, but then you're going to discover that the central limit theorem for proportions is essentially the same theorem with only one change: condition 3 and spread. Everything else is the same. So the conceptual idea of we're picking samples of the same size and, oh boy, stop that, and calculating a proportion, that's the same. How we answer the questions, condition 1, 2, 3, let's see, that's the same. How do we find these proportions? It's in StatCrunch with the same stat calculator, with the same mean and a new calculation for the standard error, but it's the same idea. So you need to get good at recognizing when are you working with a proportion and when are you working with a mean. That's one thing to keep in mind as you're going through the notes. And then keeping track of, hey, when I'm working with a proportion, what's condition 3 going to be? And how am I going to calculate the spread? Because that's the only difference between the two. So get ready for that. Enjoy it. Love it. We'll do some worksheets on that on Wednesday. So we'll do probably two things, right? The 8.2 worksheet. And if y'all don't get it tomorrow night, we can do it in class Wednesday, and then the chapter 8 review. And then we'll be done with chapter 8, and then we can start the last of the 3 last topics of the class: chapter 9, chapter 10, and chapter 11. And chapter 11 is just a repeat of chapter 9 and 10. So yes, claps, you all are almost there. And this is the exciting part. Okay, anything you all need from us before you leave?